Hello everybody, and welcome back to Space Engine. It's been, I don't know, a little bit, but I figured we can get back to this and have some more fun. In fact, I have some topics to talk about. These ring systems just look so pretty. You know, they really do. I actually forget where we are, generally. I think we're in Andromeda, and I had someone request we go to the Pegasus galaxy, so I'll be sure to do that. My cat is currently attacking the fish tank, but it's a really big tank, she can't knock it over. Anyways, so, actually, no, yeah, let's vacate this galaxy. Wait, is that the Milky Way? No, that's Triangulum. I have no idea. Well, let's get out of here. Because I do, in fact, want to go to the Pegasus galaxy because, you know, Stargate Atlantis takes place there, and it's awesome. Anyways, today I was browsing the internet, as I usually do, and I've been noticing a few articles talking about how climate change is actually slowing down the Earth's rotation. And, you know, looking at this at face value, it's like, yeah, I can see that. And, but of course, a lot of people don't, you know, they have the inability to look ahead or understand basic physics. So it's like climate change itself isn't changing the environment, or changing the spin. Alright, where's Pegasus? I wonder if I actually have its name or if I'm gonna have to, yeah, 1 second. Right then I looked up a star map. It's somewhere around here. Anyways, as I was saying, it isn't climate change itself that causes the, like, the slowing rotation. It's actually rising sea levels. And a lot of people don't actually get this, but it's like, ooh, here we go. Wait, which one? Uh-oh. Oh, let's go to both. Let's find out. It isn't like the rise. Like it's as sea levels rise. Oh yeah, that looks like an irregular dwarf. As sea levels rise, it's because the ice caps are melting, and the ice caps melt, and all the water and mass that's trapped in the polar caps, like in the near the poles, then gets redistributed down to the equator. And when this happens, it causes the Earth's rotation to slow down by a very, very, very small amount due to the conservation of angular momentum. There we go. And it's like, think of it this way, it's like if you're skating, or a figure skater, and they're spinning around, and they pull their arms in, they speed up, and when they put their arms out, they slow down. Same kind of thing happens here. It's just, you know, as the mass is redistributed, the speed changes due to the conservation of angular momentum. Anyways, so to me it was a very basic concept, and it's like, yeah, sure, it isn't that big of a deal, and yeah, the articles are all clickbaity because they don't point out that the change is very, 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 very small. But still, in all the comments, people are like, oh, this is bullshit, you know, how could this possibly be true, blah, 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 and it's like, you people must have, like, not paid attention in school, or just generally fail physics, but it's a very, very basic concept. It's very, nebulous here. Ooh! Wonderful. But yeah, so it was kind of funny just seeing these people don't understand the conservation of angular momentum. In fact, the Earth's rotation is slowing down anyways due to the moon and the tides, because the moon orbits faster than the like the tidal bulge around the Earth actually moves. So you get this bit of a lag time between the moon going overhead and the tides, and this actually causes like the tides to act kind of like a spring, and to actually start dragging the moon along with them. And this actually bleeds off energy from the Earth's rotation into the moon's orbit, and as such, the moon actually, ooh, lovely. And as such, the moon's orbit is actually speeding up, so it's actually getting further and further away from Earth by a very small amount, mind you. And as the moon recedes from the Earth, there we go. The Earth's rotation actually slows down by a very small amount. Like, it's very, very, very small. I'm talking, like, so small that even, like, 100 million years ago, there may have only been maybe an hour's difference between today and then. Like, it's very, very slow and very, very gradual. But it is still real. And, there was actually a dam built in China, one of the largest ones in the world, that made a massive, oh, that's my phone, that made a massive lake, and even that alone was comparable enough to change the speed of the Earth's rotation by a very fractional small amount. Technically, if you were to like spin if you were to like stand up and spin the opposite direction to the Earth's rotation, you would also be bleeding off energy. Or if you were to walk to the top of a hill, you'd be changing um, the angular momentum. So it's like, again, it's just basic physics. These articles need to be less clickbaity, but people also need to understand that, by climate change changes the speed of the Earth's rotation. It isn't like, oh, the Earth's going to warm up and we're going to lose and we're going to gain like hours and hours and hours. It's like, no, the Earth warms up, the ice caps melt, and the Earth slows down by a few hundredths of a nanosecond. It's more of an interesting factoid than it is groundbreaking news. So again, I get that the clickbaity aspect of it is really annoying, and I hate people do that, but at the same rate, it's still technically true. Okay, let's go somewhere else. And then, of course, people bring up the argument where it's like, CO2 levels were higher back during like the Cretaceous or some other periods, and it's like, yes, they were. Temperatures were also much higher, and the climate was also very different as a result. Because again, it's like, even at the most basic level, nobody can deny that carbon dioxide does not absorb more heat. Like, this is a very, very basic, like, this is just, It's not that, like, it's, how do I describe this? Atoms absorb different wavelengths of light, or different energy levels, depending on what element it is. And carbon dioxide does absorb lots of infrared, and infrared is what we feel is radiant heat. So it's like, the more infrared you have, the more heat you have. And again, what the hell? A brown dwarf? Oh, hell yeah, let's go there. Actually, I'll come back to this topic, because there's something else about the brown dwarf I want to talk about later. Dude, this is so cool. Anyways, so it's like, there's actually an experiment that pretty much anyone can actually conduct, and I actually conducted in school a few times, because it's very, very simple. You take two containers, and you have one that's just empty, and another one you put baking soda and vinegar in it, to generate a lot of carbon dioxide. Then you put a thermometer in each of them, and you seal up the containers, and wait a few minutes. And the container with the baking soda and vinegar will have a lot more carbon dioxide in it than the other container, and as a result, you then just put a heat lamp over both of them at the same distance, just in between them, over top of them, and wait. And when you come back, you'll find that the heat inside the one with the CO2 is actually a number of degrees higher than the other one. And this isn't because the government is magic and can somehow, break into your school or into your house and change the thermometers manually. No, it's because the CO2 just absorbs more infrared heat, or it absorbs more heat from the infrared radiation. So the container with the CO2 will just be naturally hotter than the other one because it absorbs more heat than the other one. So it's like, yeah. And again, it's like the Earth does go through cycles of heating and cooling, ice, no ice. In fact, having ice on the surface is relatively rare in Earth history. But that's not the point. The point is, is there life here? Oh, one of the moons has life. The point is that it's about adaptation to the environment. There we go. Because if you think about it, life can adapt to quite a few things. Life is pretty resilient. But for the most part, adaptation takes place slowly. Not always, but slowly. So, for example, going back to the CO2 was much higher at certain periods in Earth's history. It's like, sure, if you were to take a bunch of life now and take it back to then, most of it would probably die. Like, it's just because the environment would be so much, like the environment and the climate would be so much different that it wouldn't be able to survive. Because that's just how it is. It's like, yeah, sure, there was more CO2, but the environment was not the exact same. It was much warmer, and it was much different. So, it's like, the problem with climate change isn't that, the Earth will be ice-free and be warmer. The problem is that we're making it happen faster than it should. Because the Earth naturally will just slowly heat up and become ice-free over the next few, million-odd years. But because we've been dumping more carbon dioxide into the atmosphere than should be, that change is happening faster than it, you know, should, basically. So it's like we're seeing what should be a million-year cycle take place in only 100 years, and that is not good for anything. So again, that's where it all comes down to. It isn't that, the Earth is never supposed to be. No, it's not that the Earth is never supposed to be ice-free, or that this is nothing new. It's that it's happening faster than it should. But of course, people still think I'm wrong, and they think the scientific community is wrong because basic logic and physics is wrong because of something. I don't know. There was actually an oil company in my city I live in, because I live in Calgary, Alberta, which is very much an oil and gas industry. Ooh, aerial creatures. And there was actually a company that got into big shit because they were putting out ads and billboards talking about how the sun is what causes climate change, and that it isn't oil and gas, and that it's all wrong. But then when they actually tried to cite their sources, they found that they were actually didn't have any actual sources. They were people who were scientists, who they looked into, which were actually not scientists. They were people they paid off to write stuff, and they actually got into really big trouble for misinformation because of that. It's so stupid. It's like the the oil companies, they do have a really bad habit of trying to buy off people or to try to stop it because people who, because the idea that burning fossil fuels is bad for the environment, is bad for their business, and apparently money is more important than long-term habitability. But again, they don't understand that oil can be used for is actually used for quite a few things, not just fuel and burning. So yes, they would probably lose a lot of money if we stopped using fossil fuels as fuel, but they would still be making money off using oil and gas for production. So it's not like they're going to lose all their money. They're just going to lose a fraction of it. Oy vey. Politics. It's just weird. People seem to they fall into this bandwagony thing where it's like they don't want to believe something, so they just choose not to, despite the facts. It's like, yes, rising sea levels will slow down the Earth's rotation. It's a very small amount, but it will. That's just basic physics. Yes, carbon dioxide does absorb heat. That's just basic physics, because that's carbon dioxide, or that's what CO2 does. In fact, that was one of the ways they discovered that Venus was very, very hot. Was first off, it was giving off a lot of radio waves, and they were like, usually hot things give off radio waves in stellar terms, anyways. But then they also did a spectral analysis of it, and they found a crap ton of absorption lines in the infrared spectrum, which was showed that there was a lot of carbon dioxide on the surface, and that it was very, very hot because of it. So they were like, oh, nifty. And then of course the Russians started landing things on Venus, and that gave definitive evidence that Venus was very, very hot. I feel like we've been here before, and then I just went in a circle in terms of planets. Or maybe I didn't. Wait a minute. I'm confused. Wasn't there supposed to be two with life here? Oh, right there, that one. Ooh, exotic multi-cellular. I should probably check my phone text. That might be something important. So I'll turn off my thing. Unless it's my... oh, just someone asking if I want food. I probably do. One second. Again, my videos are not scripted, so life happens. Right then, exotic. I think tab tells us what's going on here. No, that's my journey log. Here we go. Info. Life forms exotic. I wish it would elaborate on that a bit more. But it was abiogenic, so it originated here. So that might be able to help us. Marine and terrestrial. Satellites 1. It's frozen, so it's a very, very cold planet with a low atmospheric pressure, and it's smaller than Earth. It's younger than Earth, and its orbital period 90 years. Oh my goodness. Well, it is pretty far away, so I guess that makes sense. Intriguing. Ah. I like physics. Actually, it's another thing about physics and astrobiology is that, you know, the universe is so big and there are so many planets and so many stars that any form of life you can imagine, as long as it doesn't violate, you know, the laws of physics, probably does exist somewhere in our universe. Statistically, anyways. But again, those statistics also say that, you know, any given thing you think of probably lives in some planet orbiting some galaxy a very, very long ways away from here, because the chances of it being close to us is pretty small. Then again, it's not impossible. Like, you know, there probably is quite a bit of life around us, but the chances of any life that's near us being like how we imagine is pretty small, unfortunately. Yeah. Anyways, I think I was also like what 13 minutes last time I checked. We're getting close. Oh, no, too fast. I wanted to go to its moon. Because its moon looks rather visually interesting. And it's actually like, you know, only 6 in the afternoon this time, not like in the middle of the night, as I usually do my recordings. But I just wanted to talk, because again, these articles I was reading and all the comments, it's like these people just dismiss it. Because yeah, sure, the titles are clickbaity and stupid, but if you actually read the article or just understand very basic physics, you'll find that yes, they're correct. It's just maybe they should have been a little less alarmist about it. Yeah. Oh, hello. It's my other cat. I think they're hungry. I should probably go feed them. Actually, it is around their supper time. So yeah, I'll finish this video and go feed my cats because, well, they get very complainy if I don't. What a lovely sky. What a nice, lovely desert. And it's, ooh, my goodness, it's really cold and has a very thin atmosphere. But it's still quite lovely here. It's like the moon Titan, like the actual one in our solar system. Its atmosphere is actually thicker than Earth's, but its gravity is comparable to that of the moon. So theoretically, if you were on Titan, you could strap like wings to your arms and actually like probably glide or even fly a little bit by just flapping your arms or jumping off a hill, which just sounds so awesome. And also, since the pressure is a little bit more than Earth, but it's still pretty close, you don't actually need a pressure suit or a spacesuit on Titan. You need like an oxygen mask and a really warm coat, but technically you could probably walk around but because there's no wind on the surface of Titan, you could probably just wear a like an Antarctic research parka and a face mask, and you would probably be comfortable and fine and able to explore Titan just in that. So basically, think of like people on the top of Mount Everest wearing big warm coats and gloves and boots, and then have a face mask with oxygen. That's pretty much all you'd need, really, to explore the surface of Titan. Although I would think maybe having warmed, like electrically heated gloves and maybe a heating vest would probably be better, because again, it is very, very cold. It's just because there's no wind, the amount of cold would be different than what you like what we would expect. Actually, let's go to the other. Where is it? F2, F3. Let's go to the other Pegasus just to make sure I'm not cutting anything. This is a larger one, and that would be my cat playing with chimes in the living room. That looks like a globular. Either way, I'll go to both because I'm not. I'll admit I actually don't know exactly which one. I'm pretty sure the one I was at before was the correct one, because this looks like just a small disk or an elliptical galaxy, whereas Pegasus is an irregular dwarf. So I'm pretty sure. Yeah, this isn't the one from Stargate. the one I was before was. But this is an interesting place. Let's go to the galactic center. My God, it's bright here, but it's very lovely. I like it. Let's go and look around. I forgot what I was talking about. All right, Titan exploration. Actually, even a base on Titan would be pretty easy to maintain because since the internal and external pressure would be fairly similar. I mean, the pressure outside would actually be higher than the pressure inside the dome or inside the habitat, but not by very much. In fact, the pressure is close enough that you could probably actually just increase the pressure in the habitat to ambient pressure, and that way you wouldn't actually need massive domes or pressurized environments. You could just have a pretty normal-looking environment. Like your habitat domes don't have to be able to withstand pressure and all that. They could just be structurally built and to be airtight. You're good to go. And if you have a breach, if you have a breach in your habitat, you wouldn't have to worry about decompression or whatever. There would just be very slow, mixing of the internal and external atmosphere. So you probably won't have to put on again an oxygen mask and then just go patch up the interior. But it wouldn't be as big of a problem as fast. It would just be like get to it before it becomes poisonous. But other than that, it wouldn't be like losing atmosphere or all that stuff. It's pretty cool. I'm a huge proponent of Titan exploration. Granted, I don't know if you would have a colony on Titan because again, its gravity is about that of the moon, so bone loss and muscle loss is still an issue. But a base, at anyway, a research outpost is very reasonable. In fact, what you could do is you have let's go to the star randomly. You could have a research outpost or you could have an outpost on Titan that refines helium-3 that's gathered from the atmosphere of Saturn and then shipped back to Earth. And then you could run fusion power plants here on Earth and on spacecraft, and we could have a rather awesome spacefaring civilization. That place looks pretty damn cool. Let's go there. Or you could have an antimatter refinery, or I should say harvester, in the magnetic fields of. Again, Jupiter's probably the best option. Like it has the largest, so. But if it was me, I'd have one around like all the major magnetic planets. So I'd have one around Earth in the proton belt for local collection. One in around Jupiter, one around Saturn. Maybe not Uranus and Neptune because they're. Well, actually depends. If you have antimatter spacecraft, you can get pretty much anywhere you want at a reasonable clip. So the solar system would be pretty much opened up to us. And you know what? You technically you could over time develop and have antimatter collectors around all the gas giants, and basically have fueling depots around all 4 of the gas giants, and then one around Earth, and it would be lovely. It would be fantastic. But I think that's 20 minutes, so I think I have to end it here. So thank you all for watching. I hope you enjoyed. I'll come back next time with more interesting topics. Again, I'm going to try to keep. I try not to always hamper or to go on to the whole climate change thing, but I'm a huge fan of maintaining the long-term survivability of our planet, and I'm a bit of a hippie, so I do like eco-conservation. Not like to the extreme, mind you. I also like infrastructure development, but still, it's just building a better, cleaner. Even if climate change isn't real, let's just pretend it's not, completely not. What is so wrong about building a better, cleaner future? I mean, seriously, people die from industrial pollution in the air all the time. In fact, China recently had one of the worst air qualities ever, and they're also one of the biggest producers because they use a lot of coal plants. So it's what is so bad about using clean, green energy that doesn't pollute the air? It's I for one love having clean air personally. I don't. It's I always imagine people who deny climate change and they walk around outside, on a really bad smoggy day, breathing in horrible industrial pollution, thinking to themselves, I'm really glad this is the way it is and we're not going to do anything to change it because this is how I like the world. It's like, it's so stupid. So even if you don't believe in climate change, you would think that you would at least want cleaner air and a better environment. Like, I don't know about you, it's like, but maybe, I don't know, maybe they like industrial pollution. Maybe people who deny climate change, or maybe people who like who are against climate action should just like pump car exhaust into their houses to keep the internal air quality in their house really low, because they apparently love low air quality because they're so against clean energy. It's like, it's so weird to me. It's like, even if you don't believe in climate change, why do you hate clean energy and clean air? It doesn't make any sense. I'm smiling right now because the idea is it's really, really funny, but it's just, it's mind blowing. It's mind blowing. I don't know. Again, it's all money based. People who are against clean energy generally are against clean energy because they make money off fossil fuels, and apparently poor health and killing people with atmospheric pollution is less important than money. Anyways, that little rant aside, thank you all for watching. I hope you enjoyed, and space.